Hi everyone, in this lecture we're going to be covering chapter 5 in our pharmacology book, and we will be going over drug forms. Now, as we probably all learned in our high school biology class, that anything that has mass is made up of matter, right? Matter is any substance that has mass and takes up space. And so there's 3 different forms of matter, and those forms are gas, liquid, and solid. Now, there is another form of matter, which is plasma, but since there aren't medications that are made of plasma, we're not going to be talking about that form of matter in this lecture. So when we're talking about 3 different types of drug forms in gas, liquid, or solid, the form of the drug is going to determine a few things. The first thing that it's going to determine is the route of the route of administration. So how do we give it? Do we give it orally? Is it an injection? Is it inhaled? Is it topical? All of those could be considered routes of administration. The next thing that drug form determines is the pharmacokinetics of the drug. And the pharmacokinetics has to do with the movement of the drug through the body. Remember, kinetic meaning or kinesis meaning movement. And then the last thing is the pharmacodynamics of the drug. And the pharmacodynamics has to do with the interaction of the drug with the target receptors, the cell membranes, the tissues, the organs, and the body as a whole. So there are many different types of drug forms that we're going to talk about that fall into the category of gas, liquid, and solid. Many of these drugs are a combination of 2 or more substances, and we refer to that as a mixture. Now, in a mixture, each substance still retains its own characteristics, and a mixture can be one of 2 types. Either heterogeneous, which means it's not equally distributed, the parts, or homogeneous, which does mean equally distributed. So an example of a mixture that is homogeneous would be 1% lidocaine with epi, 1 to 100,000. Now there's a really good chart on page 54, which is table 5-1 that goes over drug forms. And so here you can see examples of gas, liquid, and solid, what their subcategories are, their definitions, and some various examples. We're going to talk about some of these. So a gas is a liquid in its vapor form, and I don't know about you guys, but I just find it absolutely fascinating that oxygen's boiling point is negative 297.4 degrees Fahrenheit. So that means for it to be in its liquid form, it has to be cooled below negative 297.4. And sometimes these gases like nitrous oxide and oxygen are cooled below their boiling point so that they can be transferred more easily. Like if you ever see one of those big trucks going down the road and it says liquid oxygen on the side of it, that has to be kept at a temperature that is below that 297 degrees Fahrenheit. So a gas can extend indefinitely if it's not contained. So gases are usually stored in pressurized cylinders that we call tanks, and typically they're color-coded. However, we shouldn't just assume that because a cylinder is green, it's oxygen. We really want to check the tag and just make sure that it is the thing that we think we are getting. Moving on to liquid. A liquid is a fluid form of matter, and it has the ability to flow, and it does not have a fixed shape, although its volume does not change. A liquid will take on the shape of whatever vessel we put it in. We know that because we've seen water in a bowl or glass. If you can imagine that, any other liquid behaves pretty much the same way. There are examples of pure liquids, and pure liquids don't have any additives, and water is an example of a pure liquid. Now, within the category of liquids, there is volatile liquids. And volatile liquids are those that vaporize or evaporate really easily. Some examples of these are anesthetic agents that are inhalants. So there is a special vaporizer that is a component of the anesthesia machine, and anesthetic gases like isoflurane can be put into the anesthesia machine, and then it will vaporize the anesthetic agent and mix it with some oxygen and other agents, and then can be delivered to the patient so that they can inhale it. And typically these are used to assist in keeping the patient under anesthesia. Now, emulsions are liquids, two or more, that cannot combine. An example is, a good example that could give you a quick visual is oil and water, right? Oil and water doesn't mix, and most times they will separate out from one another, and that's called settling. So they need to be like gently shaken or rolled to redistribute the liquids. And an example of an emulsion is propofol or Diprivan. You might have heard that referred to as the Michael Jackson drug. Now, a suspension consists of a liquid or one or more solids that don't dissolve. This type of liquid is typically referred to as heterogeneous, and it has solid particles that are dispersed throughout the liquid. Again, it's going to also require redistribution before use. An example is a mixture of hydrocortisone, neomycin, and polymyxin to get cortisporin. Now, a solution is a mixture of two or more substances that do combine easily and is considered a homogeneous liquid. Okay, now the substance that is the larger amount is typically referred to as the solvent, and the substance that's the smaller amount is typically referred to as the solute. This is like putting sugar in your coffee, let's say, or in your tea. The coffee or the tea is going to be the solvent, and the sugar is going to be the solute. An example that the book gives here is saline. Now, there are different types of solutions, and the first type we're going to talk about is an aqueous solution. The aqueous solution is one in which the solvent is water. It's always water as the solvent in an aqueous solution. And again, water is referred to as the universal solvent, and a good example would be dextrose 5%. Another type of solution is referred to as an elixir. An elixir is a sweetened solution in which the solvent is ethyl alcohol. And an example of this is Benadryl elixir. Another type of solution is a syrup, and a syrup is an aqueous solution that has been sweetened with sugar. to make it taste better. And an example of this would be Robitussin, which is a cough syrup. And then lastly, the last type of solution we're going to talk about is a tincture. And a tincture is an alcohol-based solution, and you guys should be familiar with benzoin, which is the similar to mastisol, and we've been using those to before we apply our steri strips when we're putting on our dressings for the breast biopsy. That brings us to our last drug form, which is a solid. A solid is described as the particulate form of matter, and it's a fixed shape, and its volume does not change. It's not going to take on the shape of whatever we put it in, right? Think of a sugar cube, or think of an ibuprofen tablet, or some sort of solid vitamin that you take, right? Those don't change shape. Aside from tablet or capsule forms, other solid forms could be a powder. And we find this predominantly in the operating room with antibiotics. And here's an example of one right here on this slide is bacitracin, but also Ansef or gentamicin or tobramycin. Any of those will come in a bottle like this, and it will have a powder. And then that is going to get reconstituted, typically with injectable saline. The last type of drug form that we're going to talk about is a semi-solid. And a semi-solid is kind of a in between. It's not a solid and it's not a liquid. So any type of cream or ointment or gel or lotion is going to be an example of a semi-solid. It can have different viscosities, and a viscosity refers to thickness. So something with a very high viscosity is going to be more thick than something with a lower viscosity. All right. An example of this is this Providone iodine ointment is the example it gives in the book. I put a couple different images up here. I put a gentamicin ointment and a bacitracin ointment. One reason I chose these two is because it's important for us to remember that not all ointments are okay for the eyes. There are special ointments that are specifically made for ophthalmic use only. And so you can see how this bacitracin one says ophthalmic ointment, and the gentamicin, we would not want to use that in the eye. So if it's okay to use in the eye, it's going to say ophthalmic on there for us. Okay, so this lecture was short and sweet on drug forms. Might not be a bad idea to start reviewing chapter 10, as it does talk about all the common medications that are used in surgery, and there's quite a bit of information to unpack in there. So that chapter would dovetail nicely with this chapter. So go ahead and start checking that out. I hope that this lecture was helpful for you, and if you have any questions, be sure to post those as your money points, and we will answer those for you, and or we can discuss those in our Zoom meeting on Friday. Thanks for listening.